Question.
We're looking at a multi-view from the right side view. What dimensions?
Okay, so when you're looking at a multi-view, what dimensions can you, the right side, what dimensions can you pull off of the right side? Which ones?
Height and depth.
So height and depth, right? So same thing, like if I have the front view of a person, okay, front view is your most detailed view. If I'm looking at the right side, okay, so typically it's my left, your right. On the right side of the view, you can pick out the height and the depth, right? So from front to back. So what we're going to do is we'll do a review of reading a multi-view, calculating board feet, why we square a board, and then we'll be out in the lab. Okay. So the question, their answer for today is you end up getting the height and the depth for a multi-view on the right side. Okay. Why do we use multi-views? Okay, so you get multiple views. Why do I need multiple views?
Get multiple measurements.
So you can get all the dimensions off of it. Okay, so the thing with an isometric view, okay, so that's this part right up here, so the actual 3D view of it. Okay, so an isometric view, it represents an object in it's all its form, so height, width, and depth, even though it's on a two-dimensional thing. Like, so a piece of paper, you can only draw height, width, and depth, right? So we can't really measure the thickness of the paper necessarily. But with a multi-view, you have your front, your top, and your right side view, okay? And with those three views, what you're able to do is you're able to pull off the width, the height, and the depth, okay? So what you'll be given on the test, so again, the test is tomorrow, is you'll be given something similar to this, and it'll say what is like the overall height of the object. So if we're looking at this object, what is the overall height of this?
2.625.
2.625. So again, I can pull the height off of either the front, so which is this view from bottom to top, or the right side view. Okay, so I can pull off the height off of two views. Same thing with width. I can pull the width off of the front view or the top view, and depth is either the top or the right side view. Okay, so again, think of it as a person. The front would be as if you're staring at them, looking at the face. Or obviously, right, you can tell how tall you are. When someone asks how tall you are, you don't say, well, from what view? The right side are looking at me straight on, right? You're the same height no matter which way you're being looked at, right? So you're always going to be 5'9", 5'10", whatever you are. Okay. Any questions on what dimensions are pulled off of at all? Okay. Leading into that, like I said, on the quiz or on the test you'll be given a picture, something like this. It'll ask what is the overall height, what is the overall length, things like that. Then it'll ask if this was a solid piece of lumber, how many board feet is in this? Okay, so what's the equation for board feet again? What's it?
Measurement times 16.
Not time. Well, that's converting. This is converting back into fractions. So if I wanted to take,
Dimensions time divided by 144.
yeah. So it's your overall. So remember that board feet, just like with solid lumber. Solid lumber, we deal with thickness, we deal with width, and we deal with length. So when calculating how much it's going to cost for that piece, we have to deal with the thickness, the width, and the length. So basically, board feet is similar to volume. Okay. So the equation for volume is thickness times length times width. So it's the same thing for ours. We have our thickness times by length times by the width and divided by 144. Why do we divide by 144?
That's 12 by 12 by 1.
Yeah, so a board foot itself measures 12 inches wide. So if I draw this out quick. Okay, so if I have a board, it's going to be 12 inches long, 12 inches wide, and 1 inch thick. Okay, so that's a board foot. Now, when you're taking these measurements, Remember, you want them all to be in inches. So thickness is dealt with inches, length is dealt with inches, and width is dealt with inches. Okay? So all those dimensions, they need to be multiplied together, right? Because we're finding something similar to volume. But then we need to divide by 144 because a board foot itself is 12 inches by 12 inches by 1 inch thick. Okay? So if I had this problem right here, what would I end up calculating? Or what is the thickness, I should say?
What is the thickness?
Yeah, what's the thickness of this board?
What's up, bud?
0.75, right? So I'd have 0.75 multiplied by the length. What is the length? 24 and a half. What's the width? 2.625. Okay, so I'm going to multiply those all together, divide by 144. So here I have 0.75 multiplied by 24.5 multiplied by 2.625. So that gives me 48, but again I have to divide by 144. So I end up getting 0.33, I just round, just like normal in math, round to the nearest hundredth. So the answer here would be 0.33 board feet. Right? So that's how many we would have here. Now if I had two pieces, right, just like I have on my box, is the final answer going to be 0.33? Probably not, right? Because if I have two boards, I've only calculated out for one, so then I need to multiply by the number of pieces. Okay, so for board feet, you have, again, thickness times length times width, multiplied by the number of pieces. Okay. Any questions on board feet? All right. So the next part that I want to go over is if we actually have a board. Okay. So let me get my remote going. Actually, I'll just go on this back side. Alright, so if I have a board, what's the first dimension that, a solid piece of lumber, what's the first dimension that I deal with? Thickness, right? So I want to deal with thickness first. Okay, so I have a board, let's say that I got some cup warp on there. Okay, so I have, this is my board here. What is the first step I want to deal with for the thickness? The joiner, right? So remember, I want to joint one face clear. So joint one face. What percent does it need to be?
60.
Oh, not 60, 80 to 100. 80 to 100% clear. Okay? So again, that joiner, all the joiner does is it takes off this edge here, or any warp that's going to be along this board. So I have a nice flat surface to work off of. Okay? So here I have my board, 80 to 100% clear. Now what's my next step? The planer, right? So I want to plane this down to final thickness. What does the planer do again? Okay? So it deals with the final thickness, and what it does is it makes the two faces parallel with one another. Because now I have this face flat, I want to make sure that this face also is flat as well. Okay? So that's where you have your planer comes into aspect. So you have your final thickness, so planer, final thickness. And it also has your both faces parallel. Okay? Now, I've dealt with thickness. Now what do I want to deal with next? Width, right? So first is thickness, then it's width, and then last it's length. So once I have these two faces parallel with each other, how do I get one edge parallel? Not before I go to the table saw. The joiner, okay? So next I deal with width. Then I want to joint my best or my worst edge. My best edge, right? Why would I want to joint my best edge?
You can always fix your worst one.
Yeah, because you can always cut off your bad stuff. So again, say there's some bark still left down there, or there's a big ugly knot. Okay, I want to try and cut that out. Okay, so I would joint this best edge. That ends up squaring this edge up to the face. So it makes sure that my edge is square or 90 degrees to both my faces. So joint best edge. Then what do I do to get it to final width? Someone said it over here. Table saw, right? So then I take it over on the table saw. Table saw, final width. Okay, and that should end up cutting the majority of it off. Okay, so I have my thickness, I have my width. Then what do I have to deal with? Length, right? So I have my length. Why do I want to deal with the length on the chop saw? Okay, why wouldn't I want to do it on the radial arm saw? Yeah, because our radial arm saw, a lot of people use that. It tends to, it's kind of older, so it doesn't give you a nice square cut. So when I'm looking at the end and the edge, whenever you're doing finish cuts, cross cuts, you want to make sure that you do them on the chop saw. Okay, so you have chop saw, best edge or best end, excuse me, best end. Same thing is just like the table saw. When you take the chop saw to final width or to final length, when you do take that to final length, if you have any, again, nasty stuff up here on the end or any chips at all, what you want to do is square your best end so that when it comes time, you can cut the majority of that off. All right, last quick thing I want to go over is that what you guys need to do is I'm going to show on the quiz, guys. Wait, on the quiz you'll have a picture of some warps, and you'll need to be able to identify it. So you end up having, if I had a warp that was like this, what was that? A cup, right? So a cup is warped along the end. If I had, say like this, I held my board and it warped this way, what would that be? A bow, okay? And if I held it this way and it warped at a side, not a kink. Well, a kink would be straight and then it kind of kinks out to the side. Crook, okay? So we're not. I know I showed you the picture of a kink. So a crook is if it kind of curves off to the side. So when you look down the edge, you can actually see the edge of it curve. And then last we have is what kind of the worst one? The twist. So that's basically like if I held this end here and this end twisted like that. So it basically twists along two axes. Twist, really all you can do is just section that off. I said you just twist it back, throw it away. Yeah, when you have if it's a bad enough twist, depending on what it's used for, a lot of times like 2x4s, so we'll do that like in construction. You're able to kind of work that back out, depending on how twisted it is. I mean, if it's a lot, most of the times your best bet is just cut it in half and go from there. But a lot of times what you do is if you have like a warp here, a cup warp, you rip it down the middle to get rid of that. Same thing with any other of your bowls or your twists. You make a cross cut, kind of section that off. Any questions? Okay, before the end of the day, I'm going to walk around and make sure that you guys are filling out your daily questions. Okay, so make sure you bring those out in the lab. I'll walk around and make sure I get the board. Yes, a second.